What's up, DSP? This is like my 10th time doing this. It's very hard to stay within the time constraint, so I'm just going to talk super quick. My project, let me get the full screen super quick. My project was creating guitar pedals using digital signal processing techniques and coding in a language called Pure Data. From now on, I'm going to reference it as PD. Pure Data is a PD is a graphical language, so it's really visual. It makes it really easy to see how signals are being manipulated and how they're being used. The main program I'm going to focus on takes advantage of the fast Fourier transform as well as overlapping windowing techniques that we've seen in class. The general idea was to take in a continuous signal and decompose that signal into its underlying frequency bins of different magnitudes. And then once I had the signal represented in its decomposed form, I could do all sorts of crazy stuff to each individual bin before resynthesizing the signal using the inverse FFT. Here's a little picture of how a guitar string oscillates. This is sort of the inspiration for my idea. You probably already know this, but guitar strings don't just oscillate at the frequency you hear, but actually at all of their harmonics, which are then blended together to create the sound that you hear. So this is sort of like the opposite of the idea that I was trying to invoke. So this is my program. I just want to mention that Pure Data has their own objects for digital to analog converters and analog to digital converters. And while they do a lot of the grunt work for you, the programmer still needs to specify things like the sample rate, the block size, which is the amount of samples PD processes per unit time, and the overlap amount if windows are used. As you can see, my block size is 64 with 4 overlaps. Luckily, we've all learned how to choose these parameters, so picking up this language and setting the correct balance for sample rates and digital filter lengths and stuff like that wasn't super difficult. So my program takes in a signal that is initially windowed before applying an FFT. This is just to get rid of any frequency discontinuities and prevent clicking from happening. This is referred to as the analysis window. A second window will then be applied to the output of the resynthesis called the synthesis window. After applying a fast Fourier transform to the signal, then each frequency bin is multiplied by a number between 0 and 1 from my filter array. You can see that right here. This is just to get rid of some high frequency noise that my Mac was ended up recording and digitizing since my sample rate was so high. Next, I import this delay array, which changes the position at which I read from the initial buffer that my frequency bins are put into. A longer delay results in more of the buffer being read from and a better reproduction of the original sound, while a shorter delay pushes the pointer farther into the buffer, causing a less significant repeat of the original sound. The feedback array right here controls the amount of the original signal that's fed back into the system. For example, a feedback coefficient of 0 results in the user hearing that signal plus 1 repeat of that frequency. A larger feedback coefficient would result in hearing that frequency repeatedly. I have to be careful not to let that feedback array's magnitude hit 1, because that would result in the full signal being fed back and my system exploding. All right, I know I'm cutting it close, so I'm going to skip to my code. Here's my references first. You can look at that, screenshot it, whatever. So here's my two of my variables. My feedback array, as you can see, the magnitude doesn't actually go all the way up to 1, right? If you put it out sine wave of 1, it's just kind of like a scatter, which then multiplies every bin by a different amount, which is kind of crazy. I think for my recording, it was something more mellow, like something looking like that. Here's my filter. Simple low-pass filter, you've seen it. This changes the gain. This is the cutoff frequency. This is the slope. Nothing too crazy, kind of sweet though. All right, and here is a little demo for you. So you can hear those like super high frequency noises that sound like really digital and sort of annoying. Those are there because I'm playing an acoustic guitar and my Mac microphone is super sensitive, and even with the filter, some of that high frequency noise gets fed back into the system repeatedly, causing an eventual buildup of those like really sharp digital sounding noises. But regardless, you can sort of see the effect that I was going for. So thanks for listening.